topic is number system. So what do you all know what is number system? Yes, even not, then it's okay. We'll understand today in this 1 hour session. All right. Before that, before starting what is number system and what we have to study, let us understand what is Swiflearn. What is the company Swiflearn doing on this platform? Yes, so Swiflearn is a company that is known for its sincerity. So it's known as India's most sincere learning destination for classes 1 to 10. Yes, we have increased our classes. So now we are taking live sessions on our platform for the classes 1st to 10th. So by live sessions, it means that it is a proper interactive and 100% live class. That right now we are here live, right, on a YouTube channel. So the number of students who are there with me right now, which I can see, we all can interact, right? You can ask me the questions, whatever the doubts you have, that can be solved right now. But what happens to the students who watch this video later? So for that, we have made our classes 100% live. So each and every student who is present in that class, he can interact and solve that problems there and then. So you are not stuck somewhere and you don't know how to solve when you see this video maybe later. But right now, when I am live, so we can have an interaction. Yes? Okay, so best part it is that they have a personalized attention for maximum of 6 students. Yes, it's a batch of 6 students only. So we can give proper attention to each and every student, understand where are they lacking, what are their problematic areas, what are the things which they have not understood. See, I have already mentioned it before in the couple of videos and I mention it again. That see what happens in a school, there are around how many students? 35, right? And it's practically not possible for the teacher to be there to teach you at that 1 hour, solve each and every doubt of each and every question, and with each and every student, right, present in the class. Maybe someone has grasped very quickly, whereas some has a minor problem due to which he's not getting a proper answer. So this, by having only 6 students in a class, we as the teachers are here are able to concentrate on each and every student. The third thing is that we have a dedicated academic mentor team that keeps a track of the students' progress. So how the student is performing in the class, how he is doing in the homework, how much time is he taking to solve that particular homework, even that timing is taken under consideration. So we look at the timing as well. It's not that you're solving the question in more than an hour. It can be a quicker way. You are solving those questions in a couple of minutes because it's a competitive world after all, right? So we all want to score good marks and save a lot of time. So with this, the team that is working very hard and the team is analyzing the child's problem area, where is he lacking, which topic he's not able to understand. So it's not you who have to take care of this, whereas the company itself has taken care of it and have assigned a team which is looking only for your performances, and each and every performance of the student is tracked. Okay, so this point especially makes us saying that we try harder so that the student can perform to best of his ability in the exams, school exams, or maybe in the way he can understand and grasp the knowledge. The next point is that we cover the syllabus as per the school schedule. So if you have a schedule that you have a half yearly or maybe unit test, whatever you teachers and your school say that you have it after 2 weeks, so you can tell us behind. It's an example, okay? I'm not saying you have to tell us before 2 weeks, but it's just an example that if that's happening 2 weeks later, so you can tell us in advance so that we can prepare according to your school exam. So that topic is covered. Second situation, it may be that we have covered that topic already, but you want some more practice on that. So we can encourage that with you, solve those questions and give you more practice tests so that you are able to solve that in the school exam. Right. And we also handle the custom request. Custom request is like, if I know this topic, if I'm a student, okay, and I know this topic. So what will happen? I would like to learn something more, something extra, so that when I go into the new section, new class, I am little ahead of my students, right? My friends, my colleagues, whatever. So in that case, when I have to handle custom requests, so I can tell the company that, okay, I want to learn this more topic which is not in our curriculum. So company, we are there to help you with that. So we customize your request. So everything is done with the child's preference. What he wants, what is done, it's all according to the child and their parents. So with all these points, I think you will also agree that yes, Swiflearn is India's most sincere learning destination. Yes, we teach from grades 1st to 10th. So the few more key features are that there is a detailed progress report, which I mentioned before. So there is a statistics graph, which is there for each and every student. So we make it a point that when you enroll with us in couple of 1 or 2 class, we are able to analyze that where do you stand. And after that, we keep on looking that how are you performing in the class when the teacher is there to teach you, the homework that she gives you, the assignments, and you are able to do that how quickly and how accurately. So with this track, this graph is being conducted by the team, and this team takes care of each and every detail so that the child know exactly which area he has been mastered and which area he needs a little more practice. Okay, then next point is that we conduct a Swiflearn academic test series. So we call it SAT. So we conduct a SAT exams on a platform where there are many students who come to our platform and give those exams. Why do we take this importantly and we suggest the students to give is, see, we all are in a school where there are 30 students in a class, like an average, okay, and 5 sections. So after all, you are being competing with only 150 students. But does that really happen in the real world? No. In the real world, there are so many schools, so many students that are studying in the same grade. Right. So in that case, this SAT exams helps the student to realize that where does he stand in the world outside the school? Is he able to solve the questions which are given quickly, efficiently, and accurately? And is he able to compete to the world outside? So the SAT exams help us to analyze your preparations. Next point is that we provide unlimited practice tests. Like I have mentioned before, so there is no list that we'll give you these number of tests. No, we keep on providing unlimited practice tests. So because we all follow the same rule, that is, practice makes a man or a woman perfect, right? A human being perfect. So that's why we will say that you keep on practicing so that you are able to solve and understand the topic. And what are the different ways a question can be asked? So you can have the variety of ways in which a question can be asked and getting to the answers, right? Okay, and this is the best thing which I like. It is that we also provide the subjective test for the school exam. See, multi-choice, objective, we all know we have options. We can choose also if there is no negative marking, right? So in that case, we are not able to analyze. But what happens in school exams? Do we get an objective questions? Yes, you may, but you also get a subjective one. That is there for each and every grade and each and every school, right? So the subjective test, that means you have to write the answers in subjects when I'm talking of maths. Yes, and each and every steps carries a marks. If I write directly the answer, the teacher will give me hardly half mark out of a 5-mark question because she said, I don't know, have you actually solved it or not? Right? So in this question, the subjective test, when we appoint the student to do this exam, they are able to give us the answers in steps. So we get to know that are they writing the answers in the required manner which the school exams and the school teachers want us to do. So each and every point and the marks are given accordingly. So we can guide you that, okay, maybe you have got the wrong answer because you have done a minor mistake or a minor calculation mistake on the one step ahead. It's not that you don't know the topic altogether. So this subjective test helps us to analyze that actually the student understood the topic or not. Clear? So with this, I think you think that this company is doing great. So you should click on the YouTube channel subscription button. Press on the bell icon so that you never miss any update and what we are teaching live free of cost on the YouTube channel, so you are able to understand and learn with us on the YouTube channel, right? Do you all want to do it? Okay, so kindly click on the subscribe button, press on the bell icon, and if you like this video, so please click like button and share it with your friends so that they can also learn with us on the YouTube channel. Yeah, can you do that? Will you share it? Let's see. Okay, let's start. So today's topic is number system. So this is the first session, number system 1. So what are we going to do today in this session? So we will recall what are natural numbers. We will also recall what are whole numbers and integers. How do we represent them on a number line? We will record the rational numbers and the rational numbers between two numbers. So this is the base questions that are asked in the school exams, right? So before going directly to the question, let's build up the base. Let's revise what all we have done so far before coming to this grade, right? Great, let's start. So what do we mean by natural numbers, whole numbers and integers? So what are natural numbers? So we all know the natural numbers, the n is the starting n, right? Natural starts with n. So that is why we denote the natural numbers by n. So what are natural numbers? If I tell you, okay, these are a group of apples. So when do you start count them? How many apples are there? So how will you count? Will you start from 0? No, right? You start from 1 apple, 2 apple, 3 apple, and you keep on doing that till the time the bucket, the whole apples you are able to count, right? So that is naturally what the numbers start. So that is why we call it a natural number. So the numbers that starts from 1, 2, 3, 4 and go to the unlimited time so that I can calculate. So that is why we call them, the numbers are natural numbers, right? You can link it with the real life. And we denote this by capital N. Natural N, and denotation of that is also capital N. Clear with this one? Yeah, this is N and this is also N. Pretty easy, right? And that starts from 1 and then it keeps on going. Moving on to next one, the whole number. Whole number starts with W and we denote it by W itself. So denoting the numbers with their alphabets is easy. With the names, we are able to find out. Now, what is the difference between a natural number and a whole number? It's just that it has a 0 in it. See, the whole has O. So just remember that the 0 when added in a numbers and it starts from 0 and goes infinitely, we call it a whole number, right? So H, W, H, O, L, E. So this O stands for 0 as well. So the whole numbers has 0, whereas the natural number does not have 0. So now, am I able to differentiate between these two? I'm writing this very easily so that you can understand. I'm writing it big and bold so that you never have a problem. This is what happens with the students. They get confused. Ma'am, we forget what is whole number, what is natural number. So this is a little keys which you can use in the day-to-day so that you are able to recall what are natural numbers, what are whole numbers. So far, both of things we have discussed. Moving on to the third type, it's integers. What are integers? See, the difference is that integers we write with Z. Okay. Now, what happens in integers? Integers are numbers. Normal numbers, right? But in this case, what is happening is it's starting from 0, 1, 2, 3. It's going this way. Means towards all positive numbers, right? They are positive. So that's why when the numbers are positive, we don't write the positive sign. It's understood that they are positive. How about the numbers which are on this side? The negative ones. Like when I say that something gets freeze or it's so cold because the temperature has gone negative. So that is how we have got the values of negative integers. So the integers are denoted with Z. Okay. And from the negative counting, so it may be -5, -4, -3, -2, -1, and then it comes out to be 0. So all the numbers which are there, they comes in the category of integers. All right. So let's revise it again. Natural number starts from 1 to infinite. Yes. Whole number, what is the difference? It has a 0, whole. Yes. And the integers are denoted by Z, something different. Otherwise, the others two were having their first initials, right? They are noted by Z and it has all the negative as well as the positive numbers. So that's why we call it integers, including 0 as well. Clear? So it has zeros also, negative numbers also, and positive numbers also. Great. Let's move ahead and see. Let's recall what's a number line. What is a number line? So a number line is a straight line with the numbers placed at an equal interval. So this equal intervals is very important. So the gap between each and every number is the same throughout the number line along its length. It can be extended infinitely in any direction. So it can go towards the right infinitely as well as towards the left. So there is no limit. It never stops. And it's usually denoted in a horizontal line. It's usually doing that, but if we want, we can make a vertical as well. Why do we make a horizontal? Because it saves our page. Simple logic. If I'll try to make each and every number lines vertically, then how will I show the jumping? The teacher has to rotate that. So making it like little sorted so that we can see without rotating, we make the lines horizontal. So it's no problem if you make a vertical also. If you want to go out of the box, that's not a problem. But generally, we make it a horizontal line. Clear? Okay. So let's do it. What the number line is, we have discussed. The number line is a straight line which represents the numbers which have the equal distance. So this distance will be equal to this one. The gap between the numbers on both the sides will always be same. Okay, and it can go infinitely towards both the ends, right and left. It will never stop, and it is usually represented in a horizontal line. So these are the 3 points that we should remember or we should understand for the number lines. Great. Now this representation of number lines is respect of 0. It's the origin. So with 0, it starts from 0 and it can go in both the direction, positive side and negative side. So right is always positive, right? And the negative hand, when you see at the width, this always a negative numbers. So on the number line, right side starts from all positive, left side starts from all negative numbers. Clear? Yes? Great. So representation of natural numbers, whole numbers and integers on a number line. So let's see how can we make them on a number line. See the whole number, natural numbers and the integers. So first start with natural numbers. From where do we start? Where does natural number start? Quickly. It starts from 1, right? So let's see. Yes, will you see this? We can start from 1. It goes towards the right. So these are natural numbers. How about the whole? It has only one number extra. That is 0. Well done. So that means that when I add 0, this becomes a whole number. See, it starts from 0. Yeah, 0, 1, 2, 3, 4, infinite. That becomes a whole number, right? Now, integers on the number line. How do we represent integers? Integers are both positive as well as negative, the whole group of numbers. So that's why we call it these. The whole thing is integers. So from negative 8, negative 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, and then 1, 2, 3, 4. Remember, in the number line, it starts from 0, 1, 2, 3, 4. Whereas we go back, we start from same. 1 becomes positive, becomes negative. So minus 1, minus 2, minus 3, minus 4. So the counting remains the same on both the sides. It's just the positive and negatives that are being represented on a number line. Clear? Okay. So let's recall it once again and do some practice. Now you have to tell me, should I move towards right or should I move towards left? So drag the blue pointer to represent 2. So if nothing is mentioned, then what do we see? It is which number? Is it a positive or a negative? When nothing is mentioned, then the number is positive or negative? It is positive, right? So where should I go? Positives are towards right or towards left? Let me go here. No, it's becoming negative. So I have to go towards right hand side. Only the positive numbers are there. See, when I'm dragging it, I'm still not reached till 2. Now is it 2? Yeah, well done. The 2 is correct. So the point 2 is on the number line. Let's try another number. Okay, we have to go towards 10. So it's positive 10. So that's why I'll go towards right or left. Positive is always on the right. So let's move towards right. And I should go till the time I reach number 10. Let's see. Am I able to reach there? Perfect. It's 10. So still it's not coming. Why? Let's see what's happening here. Let me go ahead. No, this is exact 10. There's just point difference. That is why. See, it's 0 point something coming up. So let me drag it once again and put it exactly towards 10. So this is what is happening. So between that, if I make, it becomes a problem because we have some decimal numbers, point numbers. So see, on 10, I got it right, right? All right, so let's have some other number, minus 7. So towards minus, negative is left or right? Negative is on the left-hand side. So let's go towards negative 7 and drag and put it here. I hope I'm able to do it exactly at the time when it's required. Yes. Now it's fine? Okay, great. So moving back, we are able to analyze that positives are towards right, negatives are towards left, and the origin, the starting point of the line is always from the 0, the center point, right? Great. So we can count the numbers between 5 and 10. So the numbers between 5 and 10. So if I tell you, okay, there are two numbers, 5 and 10, and you have to count how many numbers fall under these two numbers between them. So let's see which will be the numbers. It will be 6, 7, 8, and 9. If you want to represent this line on the line, this is how. So I'll make a number line. I'll make on one corner 5 and the 10 on the other one, and the rest of the numbers will follow as 6, 7, 8, 9, like in the ascending order we make a number line, right? But what happens, how do we proceed? How do we proceed? In sides, in the natural numbers, whole numbers, integers, and now coming the rational numbers. So now what is a rational number? Till now the criteria was easy. Natural numbers, whole number, integers. Sorted. But what about the rational numbers? Where do they follow? Yes. Suppose you are planning to store numbers in such a way that they are in a collection of every number. Now, I want them to come in such a way that I am able to represent all the numbers according to the category I want. So how will we do this? See, these are the natural numbers. We know they start from 1 to 6 on the number line. So we have to put a bag and walk right way from the 0. There we will have the positive side. So we'll start from positive 1, 2, 3. So in the bag, I'm putting all the things, marbles, from starting with the numbers 1, 2, 3, 4, and so on. Whereas when I want a whole number, I'll put with it. Okay, so the next point says the collection of these positive numbers in that bag, we term it as a natural number. So the first thing, when I've collected all the positive numbers, and if someone asks me what is in your bag, I'll say I have natural numbers in my bag. Clear? Yes. Now, when I say next thing is whole numbers. How will I have whole numbers in my bag? Think of it. Yes, that's right. Now, do just one thing, that we will just take a 0 and add it in our bag. Right? So 0 is just extra. So we'll put that 0 in our bag. Now that becomes a collection of a whole number. So now I can say that I have W, the big W in my bag. It's an addition to a natural number. That is why we call it a whole number. So we added 0. Now it becomes a whole number. Moving on, now I want my bag to be a little more big. So I want to put some more things inside. So I have a big bag like. So what should I put now next so that there is a sequence? So now I will put next thing, that is, I'll put integers. How will I put integers? Now I'll put all the negative ones, because from 0 to 1, I have already put in my bag. So I now only leave the left hand side of the number line. So when I put minus 2, minus 3, minus 4, minus 5, then it converts into integers. So as we look ahead, the left direction of 0 was missing. So we will use my negative numbers like minus 1, minus 2, minus 3, and so on. So now putting those negative numbers in my bag, we have a collection of integers that are represented by Z. Just remember that. This is different. That are represented by Z. Okay. Coming to rational numbers. Now, what are rational numbers? If someone asks me, what are rational numbers? Have you got any idea how to say that? Okay. Now, after this class, you'll understand. Just few minutes give me. Okay. So we can also come across some numbers like 1 by 2, 5 by 9, something in a form of a fraction. So these are represented in a form of fractions. We call it on the number line are rational numbers. So put those fraction numbers in a bag, and the collection of fraction numbers, the negative numbers, the positive numbers, the zeros, the collection of all the things comes out to be known as a rational number. So something like a form of 1 by 2. So when I know 1 by 2, I divide, I get 0.5, right? So it would be between 0 and 1, exactly in the middle, 0.5. Same goes with negative ones. So the fractions, the numbers which I can write in a form of a fraction, those are known as rational numbers. I'll repeat myself saying what are rational numbers. A number R is called a rational number when it can be written in a form of a fraction, that is P by Q. P by Q means it's in a form of a fraction. Okay, so P by Q is a fraction. We can represent in a form of fraction, but the main reason for this that the Q, the denominator, should not be 0. Why? Because whenever I divide a number by 0, it's infinite, so I will not get any value, right? So that's why we make it a point that the denominator, which is Q, should not be equal to 0. And P and Q do not have to have any common factor. That is what we want. The number should be in its lowest form so that we know exactly where they are coming. Clear? Now, we represent this by small r. So the number r is a rational number when it is written in a form of P by Q, where Q is not equal to 0. This is the important point that you should remember. And the second is that Q and P should not have any common factor. So they should be in the lowest form of the fraction. Clear? So now, is it clear what is rational numbers? So they are like a fractions that are coming in the form of P by Q. So let's make the whole scenario, and you can take a screenshot of this so that you remember and you never forget this. So the natural numbers are the smallest one. Then it comes the whole number, which are the bigger, which includes what? One thing extra. I'll keep on writing, okay? So it's 1, 2, 3, and so on. Whereas whole number starts with 0. So if I take 0 with the natural numbers, this becomes a whole number, right? Next comes, what is it next? Next are integers that include, what do they include? Here they are positive numbers. Here it is 0. And here it is negative numbers, right? So like -1, -2, -3, and so on. Now coming to what is left, what have we studied now? Just before that, it is rational numbers. So what are rational numbers? The fractions, the numbers which can be represented in the form of P by Q, like a fraction, but the Q should not be equal to 0. So you can take a screenshot of this right now so that this is the way the whole number system is written, and this is the way all the things are sorted with their values. So if you want, I can write it in the capital. How do we denote? That would also help you. This is denoted by capital N. This is denoted by capital W. This is denoted by Z. And this is denoted by R. So I think now this is complete. And whenever you see this picture, this snap, you will never have a problem. Have you all taken it? Yes? Okay, great. So moving on to the next slide. What does it say? A new way of practicing it. Let's see, are we able to do it or not? Now, what are natural numbers? What are the symbols of that? Can you tell me? Natural numbers are the ones, they are represented by, yes, I need the answer in the comments, quickly. Natural numbers, they are represented by N. That's right. Well done. And what do we call them? They are the numbers. 0 is not included. Very good. Now integers. What are integers? They are represented by Z. Right? And what are they? They can be, what can they be? They can be positive as well as negative, right? So real numbers that are positive as well as negative. Now, positive integers. What do we write? Z with a positive sign. That means they are positive integers. Okay. Whereas the negative one, we write Z with a negative sign. That are negative integers. So what are negative integers? -1, -2, -3. They are the negative integers. Okay. Now, 0. People include 0 in this number list. So what are the ones which include 0 as well? What are they called? So 1, 2, 3, 4. Some people include 0 in this number line, number set. What is there which starts with 0? It's a whole number. So do you see any option here? Specifically for whole numbers? No. So we'll wait. Where should we put this one? Okay. Now coming rational numbers. We represent rational numbers in a form of R. Well done. So rational numbers are the numbers which can be written in a form of P by Q. Right? Like A by B, where A and B are integers. Right? Okay. Irrational numbers we haven't discussed so far. Real numbers we haven't discussed so far. So let's wait for this. We'll come back to the activity. Before that, let's start what is required in the next topic. So here comes a question for you. So let me make a tabular form so that let us see, are you able to solve those questions on your own or not? Okay. So before showing the answer, let me make this one like this. Okay. So let me see, are you able to do it or not? All right. So the question says that let us explore something more and understand what the question is about. Yes. So it says every whole number is a natural number. True or false? So every whole number is a natural number. Yes, give me the answer. True or false? It's just like a quiz. Let's see who can give me the answer first. Every whole number is a natural number. True or false? False? Okay, let's see. That's right. The answer is false. Because the only reason is that it has 0. 0 is in the whole numbers, which is not a natural number. So that's why every whole number cannot be a natural number. So we cannot say this statement is true because saying every includes 0 as well. But we know 0 is a whole number, but it is not a natural number. Clear? Great. Moving on to the next one. Let me cover it again so that you don't see the answer. Okay, moving on to the next one. Let's see. Every natural number is a whole number. Now, every natural number is a whole number. Well done, Sneha. You did the answer for the first one. Great. Let's see in the next one. Every natural number is a whole number. Is it right? Can we say that all the natural numbers are whole numbers? True or false? Yes. What's the answer? True or false? All the natural numbers is a whole number. Think about it. Natural numbers starts from 1, 2, 3, 4. Do these all come in the whole number? Yes or no? Yes. That is why the answer is true to this question. Let's see. Are we able to find it? True. Yes, the collection of whole numbers contain all the natural numbers. So every natural number, what are the natural numbers that we take? We take 1, 2, 3, 4, so on. We already don't take 0. But every natural number starts from 1 and 2 and 3. That comes in a whole number because whole number is 0, 1, 2 and 3. So if I take this and I have to put it, see if they are here or not, they are here. See, they are. So that's why we can say it's true that every natural number is a whole number. I have a big bucket, right, of whole numbers. So 0 is already there. It's fine. But if I ask you to take out the natural numbers, can you take that out? Yes. So every natural number is there in the bag of a whole number. So that's true. Clear? Okay. Moving on to the next question. Let's see. Are you able to do this? Not. Let me cover it again. Okay. So it's interesting. These questions are a little bit interesting, right? Okay, the question says, every integer is a rational number. Yes, think over it. Every integer is a rational number. Let's see. True or false? Every integer is a rational number. So integers start from, they are all negatives as well as positives. So minus, let me write from -5, -4, -3, -2, -1, and then comes 0, 1, 2, 3, 4, and so on. Okay. So can I write these all in rational numbers? Yes, I'm taking test only. You have to give me true or false. So every integer is a rational number. True or false? Every integer is a rational number. Can I write each and every integer in a form of this rational numbers? These integers can be written in a form of natural numbers. True or false? Yeah, give me the answer quickly. Waiting for your answer. Every integer is a rational number? Yes, the answer is true. Yes, they are, because the integers, that is I, can be represented in the form of I. So if I say the integer is 1, or maybe let's say 4. So can I write this as 4 by 1? This is same. And rational number says it should be in the form of P by Q, where Q should not be equal to 0. So we have 1. It's not equal to 0. So yes, every integer is a rational number. If I take negative as well, let's say -15. So can I write it -15 by 1? Yes. So similarly, I can say that yes, we can write every integer in a form of a rational number. Clear? Okay, great. Moving on to the next question. Let's see. So every rational number is an integer. True or false? Now you are able to grasp the concept. So every rational number is an integer. Every rational number is an integer. True or false? Yes, quickly. Is it true or false? Every rational number is an integer. False. Let's see, it's right or wrong. What you have given? That's right, it's false, because if I talk of a fraction, maybe 1 by 2, where q is not equals to 0, it's fine, it's a rational number. But can I say this is as an integer? No. Similarly, 5 by 6, 11 by 2, right? So in this questions, what do we say? The rational numbers, they are rational numbers, but they are not have an integral value. So they are not an integers. So that is why we say it's a false. Well done. Great work. Okay, moving on to the next question. Let's see who can do it. Every integer is a whole number. Every integer is a whole number. True or false? Yes. Every integer is a whole number. True or false? Every integer is a whole number. So whatever integers which I can have in my mind, I can say that they are whole numbers. True or false? The answer is false, because the negative ones don't come in the whole numbers bag. If I have a whole number bag, that starts from 0 to the positive side. But when I talk about negative numbers, they are not in the bag. So when they are not in the whole numbers, then how can I say it's true? It's false. Well done. So every integer is not a whole number. Clear? Okay, great. Moving on to the next one. The next one says question number. Okay, so it's no question. It's something which I wanted to tell you, that have you ever thought of this or not? So is 0 a rational number? So when I say is 0 a rational number, is it true or false? Yes, if I say 0 is a rational number. I'm telling you 0 is a rational number. Will you agree with me, or will you say, no ma'am, you are saying something wrong? What will you say? You will agree, right? It's true. Let's see. Why are you agreeing with me? Because 0 is a rational number. As per the definition, we can say 0 by 1. So a rational number is written in a form of P by Q. This is what the definition says. It should be in a form of P by Q, and Q should not be equals to 0. So the denominator should not be equals to 0, whereas the numerator on the top can be 0. So I can write 0 by 1. So yes, it is in a form of P by Q. There is no definition in which saying that P should not be 0. It's only saying that the denominator, the lower number, should not be 0. But the top one can be 0. So that's why 0 is a rational number. Just remember this. This is what the children makes and get problem. They may get confused that 0 should not be there. So it's not there. So how can we say it's a rational number? And this is the question that is asked with number of people and they give a wrong answer. So now you are being smarter than that after attending this class, right? Yes. Now if someone asks you that is 0 a rational number, you will definitely say this. Yes, it is a rational number. I have understood and studied at the Swiflearn live YouTube class. Will you tell them? Great. So the rational numbers, I'll repeat myself. The rational numbers are written in the form of P by Q as per the definition. So P can be 0. That's not a problem. But the reason is that Q, the lower number, should not be 0. So 0, I can write it by 0 by 1. That's why 0 is a integer which converts it into a rational number. Clear? Okay, so rational numbers between two given numbers. So if I ask you if a number A and B are given to you and I have to find a rational number. So how do we calculate? We add A plus B and divide it by 2. So we get the numbers in between. Whereas when the A is bigger than B, in this A and B are bigger. Whereas when A is bigger than B, then we divide the same logic. But now A will be the bigger one and B will be the smaller one. So this is a rule and we will use this the next questions which are coming up. Let's see how. So if I tell you find out a rational number between 1 and 2, how can you find out? So 1 plus 2 comes out to be 3 because the question says, okay, A is 1, B is 2. So A is smaller and B is a bigger one. So the formula is A plus B by 2. So it should be 1 in the form of this. It should come here. How do we calculate A plus B? That means 1 plus 2. That comes out to be 3. 3 by 2 is the answer. Clear? Now this is easy to calculate when I tell you two numbers. So you just need to add them and divide by 2 will be the fraction that comes in between them. So there is another way of finding rational numbers which are generally asked in the school exam. Like find 5 rational numbers between 1 and 2. Now, for calculating 1, it is easy. Just add those 2, divide by 2. It's easy, I can get 1. But now when the question says, tell me 5 rational numbers, then I have a problem. I don't know how to do it because I don't have those different logics. So the easy way out to do is, how much is he asking us to do? He's telling us to do 5, right? So 5, let's say 5 is a number because that is asked with us. We'll add just 1. Whichever the number is given, we'll add 1. So what is 5 plus 1? It comes out to be 6. Now we will multiply by 6. 1 multiply by 6 by 6. It will not be a problem, right? So what does it come out? 6 by 6, right? And now 2. 2 will also be multiplied by 6 and divided by 6. So that is also not a problem. That comes out to be 12 by 6. Now I have a fraction 6 by 6 and I have a fraction 12 by 6. So what will be the fractions will come in between? So that has to have a denominator 6. So I can make how I want. Now after 6, what the next number comes? 7, then 8, then 9, then 10, then 11 by 6. So these are the 5 things I'm easily able to calculate. Now what have they done? 7 by 6, this is clear. Coming to 8 by 6. What happens to 8 by 6? See, 8 and 6, they are even numbers. So they are divisible by 2. So on dividing, what do I get? I get 4 by 3. This is what they are giving me the answer. Now 9 by 6. I can divide both the numbers by 3 because they come in the 3 table. That comes out to be 3 by 2. This is what they are given. Same logic, 10 by 6 divided by 2, 5 by 3, 11 by 6. So what have we done? How many questions are they asking us? 5. So we'll add 5 plus 1, that comes out to be 6. Multiply by 6 and also divide by 6, so that the logic remains 1. Right? If I'm multiplying with the same number and dividing with the same number, I'll get the number itself. So that is what we are doing with the same two numbers, and by this we are able to calculate the other 5 numbers, other rational numbers between them. Okay, so let's do the other one. Now what's happening is they want us a rational number, but the numbers are also given in the form of rational numbers. Now, what do I do? Same logic, not a problem. Why should I get confused? Okay, they want me 5. So I'll do 5 plus 1. That comes out to be 6. Now 3 by 5, I have to multiply by 6 and divide by 6. That comes out to be 18 by 30. Same, I'll multiply 4 by 5 is given. Okay, I'll divide and multiply by 6. It comes out to be 24 by 30. Now I have 18 by 30 and 24 by 30. So see, I have such a wide range. So I can make so many out of 30. So it can be 19 by 30, 20 by 30, 21 by 30, 22 by 30 and 23 by 30. So on solving them, because we have to keep the rational numbers in the lowest form. Remember I told you that they are called rational numbers when they don't have any common factor between P and Q. But right now I can see they have a common factor of 10. So that would 2 by 3 will be the right answer. Clear? Similarly, you can solve rest of the fractions and you will get the answer. So these are the fractions. So on solving this, you will get the answer. So now useful properties of integers, that is very important, and you should understand that what are the properties, and these are the properties that are used in the questions. So concentrate more, right? Great. The sum of all the integers will always be an integer. So if I add two integers, let it be 1 and 2, will it be some rational number or something else? No, it will be an integer, right? 3. So that is what an example says, that if I add 6 plus 4, it comes out to be 10, an integer. 6 plus 1, 7, integer. 4 plus 2, 6. 5 plus 9, 14. Clear? So addition is clear that when we add two numbers, we always get an integer. Now, when we subtract two integers, we will always get an integer. Yes or no? Yes. So how will we do that? See, if I say a fraction 3 minus 6, even if the bigger number I'm getting subtracted, but I'm getting a negative number. But that negative number is also an integer. It's a negative integer. So that's the right answer. So minus 6 minus 7 is minus 13. So that is also an integer. Minus 6 minus 5 comes out to be 9. Minus 2 minus of minus 3, that comes out to be 1. So yes, when we subtract two integers, we get an integer. Moving on to the third one. Product of two integers is also an integer. Pretty easy. When I multiply two numbers, two integers, I'll always get an integer. That is always happening. Like 7 by 7 into 6 comes out to be 42. Minus, negative, negative becomes positive. Then it's 9 into 2 is 18. When I multiply a positive with a negative, I'll get negative. But that is also an integer. Same is the logic with minus 5 and 8. Clear? Now comes the interesting part. What is exceptional? So far we have understood that when we add two integers, we get an integer. When we subtract two integers, we get an integer. When we multiply, then also we get an integer. But what happens on division? Do we get an integer? It is not necessary. When we divide, A and B are two integers, and when we divide them, it is not necessary that we get an integer. Instead, we may get a rational number or an irrational numbers. Let's see how. 16 by 5. Both are integers, but on dividing, do I get an integer? No, I get something like points. That is not an integer, or maybe like a fraction. 16 by 5. It's a fraction. They don't have anything common. Same. Minus 9 by 4. So both are integers, but there is no common factor. So they are remaining in a form of a fraction P by Q. So they are rational numbers. So let's solve this quickly. Integer plus integer is a, what is it? Integer. I'm writing with Z so that we remember their symbols. Integer minus integer, It is an integer. Integer into integer, it is an integer. Is it equal to integer? No, it may be equal to an integer. That is not a rule. Clear? Yes? Okay, great. Moving on to the next thing. Let's see what's the next property. The next property is adding two numbers. So adding two rational numbers, what happens? Adding two rational numbers is always a rational number. Let's see, are we able to do it or not? So there's an example of a fraction that says 7 by 3, 4 by 3. So it's a fraction. Denominators are same, so I can add. So that comes out to be 11 by 3. So is it a rational number? Yes. Now 5 by 9 added to a negative fraction. Negative rational numbers. I can get a negative as well, but is it a rational number? Yes. Because I'm doing addition with a negative one. So even if I'm performing a negative, this subtraction method, but actually what I'm doing, I'm adding. Okay. Now moving on to the next, subtracting two rational numbers is a rational number. So similarly, when I subtract two rational numbers, I get a rational number. Right. Moving on to the third one property, multiplying two rational numbers, also a rational number. When I multiply two numbers on solving, what do I get? A rational number. Yes. Same here. When I multiply two numbers, negative has to be cancelled. There's some error in this one. On solving, we'll get a fraction, but that will be a positive one. Clear? Okay. Now, what happens on division? If I divide a rational number with a non-zero rational number, so the rational number should not be 0 because we have understood before that 0 is a rational number. But if it is a non-zero, then only will I get the answer as rational number in a form of P by Q. But when I multiply it by 0 by 1, I'll get the answer 0, which is an integer. So that is why this property is important, and we should remember that if a rational number is divided by some non-zero rational number, so it cannot be like 0 by 4 or 0 by 1 because this all means equals to 0, right? This means 0. So when it means 0, then we multiply it or divide it by it. So division by 0 is not possible. So it has to be non-zero. That is why we call it is a rational number when it is done with non-zero. Division is done. Clear? So then it's always a rational number. Otherwise, we cannot determine the value of it. Clear? Okay. So let's revise quickly. Rational plus rational. Will it be a rational or not? Will it be a rational number? Yes. Rational number subtracted by a rational number will also be a rational number. Rational number multiplied by a rational number will also be a rational number. Whereas when we divide and the other fraction is a non-zero rational number, then only the answer will be a rational number. Clear? Yes? Great. So let's solve this. How do we solve these questions? So this is a test. Okay. Let's solve. How do we solve these questions? So it is a fraction with different denominators. So how will we do it? So it's 9, 12 and 18. So we know we cannot add a fraction when they have different denominators. Instead, we will find out the LCM, lowest common multiple of these numbers. So finding the LCM, we have already started in our 4th and 5th grade, right? How do we calculate? So we know how to calculate. 3 is a common one. 3, 4, 6. Now what comes a common 3? 1, 2, 3. Now again we can do it by 2 if I want. Okay, 1, 1 and 3. So 3 into 2, 6. 6 into 9, 9, 18, 27, 36. So 36 is the LCM. Now what will I do? I'll take 36 as the bigger LCM. I already have 9, so I'll multiply it by, what will I multiply? I multiply it by, already have 9. So on the top of the 6, to make it 36, I have to multiply by 4. 9 4s are 36. So 6 4s are 24. Similarly, when I have 12, I have to multiply by 3. So 7 3s are 21. 18, when I have to make it 36, I have to multiply it by 2. So 11 into 2 becomes 22. On solving this, I get the fraction that is 19 by 36. Clear? Great. So this is how you have to do. Now I'll give you a question. Let's see who can give me the answer. Quickly tell me, solve this and give me the answer in the comment box. So what is the answer for this? 9 by minus 10, 4 by 15, minus 3 by 20, minus 3 by 10, 8 by 15 and 9 by minus 20. So quickly tell me the answer. What is it? Okay, so this answer, I want each and everyone who's watching this video, maybe right now, maybe later, to put this answer in the comment option, and I'll show this answer in the next class. Let's see who all are seeing this video and solving this question. Who all have understood with the Swiflearn online platform. This is a quiz and a question for each and everyone who's watching this video with us and understanding with me. Clear? So I think you all can take a screenshot of this and solve it. So I'm moving ahead, giving you couple of seconds to take a screenshot and solve it later. All right, great. So moving ahead, the question is, these are the things that you can do in your excess time. This is the way you have to solve and give me the answers. Before the next session, can you do this all? So that we can discuss these questions, and if you have any problem, then I'm here live teaching you on the YouTube platform, right? Okay, so these are the 3 questions and the one earlier. So there are 4 questions that you need to practice before the class and give me the answers in the comment box. So I'll also read the comments which you give after this video. Okay, let's see, are you able to solve this or not? Great. So answers we'll explore and show it in the next class. So today, what have we studied so far? We have studied what are natural numbers. We have recalled whole numbers, integers, given a practical experience of that, represented on the number lines. We have also discussed the rational numbers and the practical questions that are asked in the school exam, that to find how many numbers are between a rational number, and a trick to solve that when we don't know that we have 2 numbers and we have to find more of a rational numbers. Clear? Great. So now one thing, a new tip. Every odd number has E in a number. Think over it that each and every odd number which you can think in the whole number system, it has an E in it. So let it be 1, 3, 5, 7, 9, 11, 13. Keep on doing it. So you got a tip and a new thing in the number system that is out of the box, that is different, that we have never thought of, that every odd number which is there in the number system, their names are designed in such a way that it will always have one E alphabet in it. Something new? Yes. Okay, thank you so much for today's session and taking out time and understanding and learning with me. Till then, take care, bye-bye, and kindly click on the subscribe button, press on the bell icon so that you never miss any update of the YouTube channel. And like, comments, share with more of the friends of your classes so that they can also understand and study with us on our platform. And the best part is that Swiflearn is giving a free trial class to you students who are there with us. So you can go subscribe with us right now in the YouTube channel. Secondly, you can also take a free trial class and experience the real experience, the first-hand experience of getting taught by an online teacher live at your home, and see how do you like the company. Great, and we are not charging anything for that. So I hope to see you all in my classes, the regular Swiflearn class where I'm teaching. I can find, and you can come and say that, ma'am, I saw your YouTube channel and I'm coming here to learn from you. So that I can see your faces as well. Yeah, great. All right, take care. Bye-bye. It was great fun having you here, and I hope the same was with you and you have understood the topic more better, and now you're clear and you're prepared for the next session that will come in the near future days, right? Till then, take care. Bye-bye.